As we build our application, are we adequately preparing it for the dangers it may face? Welcome to Defensive Coding in C#. My name is Deborah Kurata, and in this course we examine techniques for shoring up our code's defenses to better prepare it for the perils of the real world and real users. What are these dangers we need to defend our code from? Incorrect entry, invalid operations, system mishaps, and future developers? Let's look at a quick example of each of these. Our users are depending on our application to produce correct results. But to produce correct results, the user must input correct data. We defend our code against incorrect entry by adding appropriate user entry validation. For example, say our corporate standards limit a product name to 32 characters so it fits on the customer's invoice. To protect our code against incorrect entry, we validate that the product name is not empty and not more than 32 characters. We also want to protect our application from invalid operations. To produce valid results, we must pass accurate data into our methods so that they can correctly perform their operations. We defend our code against invalid operations by checking arguments passed into those methods and by fully unit testing the operations. For example, say our application calculates the profit margin for a product given the suggested price and product cost. To protect our code against invalid operations, we confirm the price and cost are numeric and that the price is not zero before attempting the profit margin calculation. And we fully unit test the calculation using valid and invalid inputs. When working with software, there's always something that can go wrong. The user loses connectivity just as they attempt to save their data, or the storage device used for logging user actions suddenly fails. To protect our code from these mishaps, we add checks and manage exceptions. For example, we check that the network is available before saving, throw an exception if the network fails, and save the data locally until the network is reconnected. Lastly, we protect our application from future developers, including our future selves that may not remember why we added that particular line of code. You may have seen notes in someone else's code that suggested, "Here be dragons," meaning that the piece of code was complex and could cause issues if refactored without comprehensive knowledge of its purpose and side effects. If our code is not clear and another developer doesn't understand our intent, they may make incorrect assumptions about that code and make inappropriate changes, causing our code to fail. We defend our code against future developers by writing clean code, which is code that is easy to read and comprehend, and by having a thorough set of unit tests to verify that any future change does not negatively impact the application's functionality. Notice that we didn't mention defending our code from malicious users. Improved validation can prevent some security issues, such as SQL injection, but there is much more to securing our code. Secure coding, user authentication and authorization, and database security are large topics that are out of the scope of this course. Search the Pluralsight library for courses on these topics. Now that we know what we are defending our code from, let's take a closer look at what defensive coding is.